Welcome to the lecture series on vitamins and nutrition. Today we are going to continue from the previous session about vitamin E, its absorption, distribution, metabolism and deficiency conditions. Now we have seen already the historic aspect of vitamin E. Today we are going to look into little more details on the historic context of vitamin E and how vitamin E has an essential role to play in deficiency conditions. Although deficiency conditions for vitamin E is quite rare, but still vitamin E actually helps in the overall betterment and metabolism of human physiology. Now if you look at this picture, this table, you will know there is a period, I would say way back in the 19th century, most of the vitamin discoveries have come into play, and this category, if you look at, is a mixture for both fat soluble vitamins as well as water soluble vitamins. Although we have seen in detail on various aspects of historic content concerned with vitamins. So this particular table gives you an overall picture of the historic flow of discovery of vitamins. Now you see over there, almost I would say the vitamin which was under detailed study were water soluble vitamin, especially thiamine, followed by vitamin C, but you find other vitamins were also had been given equal attention over a period. Now if you look at vitamin E, here you have vitamin E as basically was proposed the structure or its role in 1922, followed by its isolation and structural determination. Most of the essential vitamins as we have today, the essential list of vitamins and minerals, most of them have been done through a very systematic diet deficit disease experiments in animal models, and vitamin E is one such example. So we have seen in the last session how vitamin E discovery really emphasized its role in the fertility aspects of animals. Now we always have this problem whenever you do any animal experiments, although we select the kind of animal system that will have much close resemblance to human physiology, yet there are some deficits here and there. So especially for vitamin E, the experiments what came out well in the animal system and its role established in animal system cannot be completely extrapolated in human system. It does not undermine the role of vitamin E in human physiology. Yes, we have derived a lot of understanding for vitamin E, but here you look at this, in this particular time period you always find a time interval of nearly more than 10 years where people propose the structure, then propose the role of a particular vitamin, then they look for the evidence of that particular vitamin by, I would say, deficit diets in animal system, then they come up with, I would say, the proposed structure. They try to isolate this, they try to synthesize it, and then they try to supplement with a synthesized derivative and see what role it might play. Many of the vitamins function has been already established, and now if you look at it, here we go, this entire list. This list basically almost follows the chronological order of its discovery and reporting of its structure, and you find vitamin E, it was investigated since 1922, then I think in 1936 they were officially isolated and characterized, and you find somewhere during the Second World War the role of vitamin E was established. Now this discovery of vitamin E and most of the vitamin E discovery circles around, I would say, the Second World War time really helped the rations of soldiers and rations of people, because most of the diet which has to be given for soldiers and for all patients who are suffering in hospitals, this concise list of vitamins and their role in human nutrition was very favorable, because all the food can be efficiently fortified for these vitamins, and this would have ensured a very good balanced diet available for recovering patients and for soldiers. Now if you look at vitamin E, we saw already vitamin E's role It's more concerned with germinal epithelium in animal models. That's true. So they played a very important role for normal live birth in mice model, but if you look at human system, their major role was more into the effect of antioxidant function that they played in human system. Now exactly what they would do, how do they act as an antioxidant? So if you look into the role of antioxidant, we saw elaborately in the last session how their antioxidant role plays a wonderful role in restoration and maintenance of highly proliferating cells, and especially when human physiology is under, I would say, a free radical attack, because we cannot avoid all the metabolic functions. It keeps happening every now and then. Every living cell or every living tissue for that matter is metabolically very active. So if you look at, so this is just a recapture from the previous session. So from there we will take further and look into the deficiency diseases. So you look here, the cell membranes which protect the every cell in our body actually is also a kind of a entry point for most of the substances to find its way inside the cell, and being a boundary, it needs to be regularly maintained for any kind of membrane related damages happening over there, and it will house plenty of enzymes, and these enzymes, many of them help in the self repair mechanisms. So you see over there the phospholipids, which are the bilayered layer which forms the boundary, being frequently damaged because of the free radicals. So the source of free radicals would be from the cytosol obviously, and also you could expect free radicals being released as part of any metabolic activity. And now let's consider this membrane, which is basically the membrane that surrounds every cell. And now depending on the cell, suppose you consider certain cells have a high level of metabolic activity, producing more amount of free radicals. Let's say for example the hepatocytes, the liver cells, they are always very actively engaged in metabolism, not only in the normal physiologic response of the cell, but they also help in clearing many xenobiotic related compounds from circulation. So they would obviously be involved with many chemical reactions, and these chemical reactions would naturally give rise to plenty of free radicals. So these free radicals have to be removed, or rather I would say dampened, before they could cause any damage. But whatever the case, some of the free radicals would escape and they would find their way in the cell membrane, damaging the parts of cell membrane. So you need to act like a kind of a provision to dampen these free radicals to really provide a protective effect. Something like, you throw a band of fire and immediately you use an extinguisher to quench down the fire, or else once the fire is lit, it becomes much difficult to really control. So similarly, once the free radical initiates damage to the cell membrane, it's much difficult to really counteract. So what we have to do at a very early stage, before free radicals could initiate a reaction, if membrane could find some way of having to directly neutralize these free radicals, most of the damage could be, I would say, prevented. So now vitamin E in the cell membrane actually does this. They neutralize the free radicals. So how do they neutralize the free radicals? There are different mechanisms by which they neutralize free radicals. One would be like free radical hydrogen peroxides can directly be picked up by vitamin E, because we saw in the previous session the structure of vitamin E and how vitamin E accommodates effectively in neutralizing. See, always remember, whenever we talk about free radical being neutralized, or whenever free radical would interact with any other species, it's more likely the free radical would try to pass on its legacy to the new compound. So in this case, vitamin E also picks up the free radical in the process of neutralization, and this in turn produces or becomes a kind of a free radical, but this one is quite less reactive compared to the free radical or oxygen species of the free radical that causes quite a outstanding damage to the membrane. Now this one gets self annihilated, or rather I would say quickly dissipated, and thereby, although this picture shows as if vitamin E is like directly neutralizing the effects of free radical, it's more like the free radical passing on its electron to the vitamin E system, because it's having a conjugated system, and they are able to carry over, in a sense, exhibit their antioxidant effect by minimizing the damage caused to the cell membrane. So this is what we mean by prevents oxidation of LDL cholesterol. So LDL cholesterol is one of the key components of lipid metabolism, and they prevent the oxidation of LDL cholesterol. So oxidation of LDL cholesterol can eventually trigger a series of inflammatory molecules, which could be difficult to really have a grip when we do not have any antioxidant based mechanisms available. So vitamin E constantly is vigilant in trying to protect the membrane. See, whenever we talk about any membrane or a vitamin, for that moment when we look at that particular vitamin, we like attribute all responsibilities to it. So but in reality, if you look into the biochemistry of a cell, actually all these vitamins and other components and endogenous substances are all working in concert, in the sense they help each other. There is a cascade of reaction happening, and that's how the overall metabolism is studied. So when we do normally one at a time. So we look at vitamin E as if the great person directly neutralizing all the free radicals available or generated in the cellular process. Now if you look at this, what all different changes that they are into, this also we saw in the previous session. Now I am just elaborating a little bit more on the components in the context of deficiency conditions to expect in case of vitamin E. Now if you look at it, the mitochondrial membrane, and every cell for that matter, metabolically active cells have mitochondria, and every cell mitochondria will be engaged in providing the necessary energy for cellular function. So the mitochondrial membrane in turn, I would say, is embedded with many of the electron transport systems. So you see over there, they stabilize the coenzyme Q, and you do have oxidative phosphorylation happening in the mitochondria. Now we already saw vitamin A and carotenes, how do they play a role. RBC membrane, which is extremely sensitive and liable for, I would say, any kind of free radical damage, actually can be prevented from homolytic anemia. It means what? Self destruction of RBC, or RBC membranes being under threat by free radical. Now you do have, I would say, these two structures, especially RBC membrane and muscular membrane. Can you see over there? Tissue with high oxygen consumption. So what do you mean by that? Whenever you find any tissue which is likely to be a good source for generating free radicals, which tissue? None other than those tissues which are extremely active. Let's say RBC, because RBC carries hemoglobin, and hemoglobin gets complexed with oxygen, and oxygen, molecular oxygen, gets transported across. So in that case, you could expect every RBC would be so active in transporting this cargo of oxygen inside the cells, and this being an extremely sensitive cargo, which could be a potential source for free radical, oxygen derived free radicals and other related free radicals. So you see over there, so RBC membrane is of high threat because of the free radical propensity being developed inside the RBC cells. Similarly, you consider muscular membrane, because muscles, whenever they do any work or function, you could expect energy being released for the muscular activity, and this involves lots of complex metabolisms happening inside the muscle, and without which the muscle will not be primed with energy to perform its function. So you see over there, naturally, of all the metabolic activity, oxidative metabolic activities are supposed to be more efficient because they instantly release the energy, and you find muscle membrane, I would say, who's also been endowed with mitochondria, and this mitochondria would work in tandem inside the muscular membrane, helping the muscular membrane, I would say, producing necessary energy for the normal cellular function. So, you see over there one more structure, hepatocyte membrane. This we already discussed as to how liver being one of the very active organs responsible for metabolism. Now, this point, what we call it like germinal epithelium of gonads, I would say is being directly attributed in the reproductive function. Now, you look at this, the germinal epithelium of gonads has more to say in the animal model than in the human system or physiology, but does not rule out that they do not play any role in the germinal epithelium. Obviously, they play an extensive role, but the way the deprivation of this particular vitamin creating an impact in those tissues is still not very clear, or rather its role is relatively bleak. But overall, the role of vitamin E as an antioxidant in all these metabolic, I would say, conditions where high metabolic rate is expected because of the resulting muscular activity or RBC being engaged in transporting oxygen. So, these structures could be considered as high alert or red alert structures, where their tendency to have exposure to free radicals or potent free radicals is always there. Now, if you look further, in what way we are going to look at the deficiency of vitamin E. Practically, vitamin E deficiency is very rare, extremely rare. If a person is going to have deficiency, obviously it could be deficiency concerned with other substances which are also part of deficit in the diet whatever the person is taking, or rather I would say this way, it is not like exclusively there is vitamin E deficiency. If there is an overall deficiency of fat soluble vitamins, vitamin E will also be part of that particular group of vitamins performing specific functions. Now, if you look at this, it is quite interesting to look, I would say, causes of vitamin E deficiency. Why we have vitamin E deficiency? The reason is the first deficiency what we consider being the dietary insufficiency. Most of the bacteria in the gastrointestinal tract are responsible for producing vitamin E. Although any germ rich layer, I would say the germinal oil from wheat germ sources provide exact source for vitamin E, but there could be also dietary deficiency which could match with a long term dietary deficiency of fat soluble vitamins. So, inclusive of all the fat soluble vitamins, vitamin E deficiency would also be there. Then what we call it like sprue, which is also called the tropical sprue. This is a condition where we have problem in the gastrointestinal tract where absorption becomes an overall issue, because you see the brush border, I would say a layer where most of the absorption happens on the surface gets affected. It is a kind of a degenerative condition, especially the villi and all those layers which have been exposed to effective nutritive substances undergoes certain degenerative changes. It could be because of infection, it could be because of dietary changes. In any case, sprue could be a reason where practically there is no absorption of any nutritive substances, and vitamin E deficiency will be inclusive of that deficiency in absorption. In addition to that, for people who suffer from bile stone or gallbladder diseases, who do have problems with secretion of bile, would also may have the problem of lack of bile salts in the normal secretion of bile process, bile secretion in the gastrointestinal tract. So, if you look at it, why this is of much importance? Because not only for vitamin E, as we have been looking at, bile is the key emulsifier of any fat or micellar substances that has to go into absorption. So, you find over there vitamin E being a fat soluble vitamin, and if you do not have bile salts, there would be naturally a problem concerned with absorption, because it cannot be emulsified, it cannot go across, and obviously there would be a persistent delay in the amount of vitamin E that reaches systemic circulation. Second thing, if you could consider any people who have already underwent problems with bile secretion, or I would say cholelithiasis, bile stone creating an obstruction in the biliary tract, or probably people who already underwent, I would say, gallbladder removal, okay, cholecystectomy we call it, it's been removed. So the provision of regular availability of bile compared to a normal individual, there would be fluctuations, and this can on a long run could make them deficit for fat soluble vitamins, and in this case it is inclusive of vitamin E. Then pancreatitis. So pancreatitis is a condition where inflammation of pancreas would be there. So this could sometimes lead to a cancerous condition. Then it's like one of the most dangerous diseases, I would say, inflammation of pancreas. And because pancreas houses plenty of proteases which are extremely effective in digesting tissues, proteinous material, now it will start self digesting. As a part of it, it could result in vitamin E deficiency. Now steatorrhea. So what is steatorrhea? Steatorrhea refers to passing of stools with fat or oil. So in this case, many of the oil or essential nutrients and fats have been deprived for different reasons, and this actually could be one of the reason why the fat which has to normally get absorbed after being converted into the micellar source, here they suffer from lack of absorption, so that most of the fat which is unabsorbed is eliminated in the, I would say, gastrointestinal tract. So that's what we call it like steatorrhea. And then you have hypolipoproteinemia. This is also a genetic condition where you consider there is a generalized decrease in the production of lipoproteins, because lipoproteins play a very essential role in the transportation of lipids across. So you don't have lipoprotein sufficient enough, and maybe this may not be seen immediately, but over a period they will start showing symptoms. Now if you're going to look at what are symptoms that they show symptoms for all fat soluble vitamins, and this will be inclusive of vitamin E. Now if you look at a quick summary of what we have done, so this list now matches with this, and this gives you a little insight as to what exactly this deficiency is all about. So as I've told you, it will be a degenerative muscle disease. I have not highlighted on the sterility aspect because sterility conditions are more common in animal model than in human system, whereas degenerative changes in muscle is quite common, because I would say people who are already suffering from degenerative conditions now can be actually, I would say, related with vitamin E related functions, and over a period they could themselves end up in severe degenerative changes. Or rather, let's say people who suffer from multiple sclerosis or any other muscular diseases, let's also consider myasthenia gravis. In such diseases, if you are going to supplement the patient with vitamin E, you do find tremendous improvement. So this tells you the degenerative changes could be inherent, or it could be a result of a pathology, and supplementing with vitamin E could have positive response. And for people who already have these conditions, or probably a preliminary version of it, and if they are deprived in vitamin E, then that might escalate or create a negative prognosis. We also look at megaloblastic anemia. So what is megaloblastic anemia? It's an anemia where RBC membrane is involved, where in megaloblastic anemia it is an anemia resulting primarily because of nutrient deficits, those nutrient deficits which are concerned with the proliferation of rapidly growing cells, especially the healthy ones. Now you have changes in the central nervous system. So what are these changes? So central nervous system, when we talk about it, neurons and neuronal membranes are very, very important in terms of nerve conduction. So any change in the nerve could actually create a problem. So how do you consider this? The problem in the nerve would be mostly as a degenerative changes observed as a change in the neurolemma. So what is this neurolemma? That is a membrane which surrounds the nerve, and they are also, like RBC membrane or mitochondrial membrane, is subjected to lots of oxidative stress, and vitamin E deficiency can cause a degenerative changes over there. So finally I could give you this picture, so you could actually visualize those symptoms by yourself. See over there, as I've told you, sprue and other conditions can result in vitamin E, and vitamin E on a prolonged period of time can have more degenerative changes. Yeah, this is very common as a cosmetic component. You would consider it to be air loss as a feature. Then the muscular degenerative conditions can result in difficulty in walking, and overall asthenia, what we call it, like weakness in muscle. Then yes, lack of libido, but that's not very profound in human system. And you could also consider vision loss, because you could expect cataract. So you see over there, so there is propensity of cataract, and for people who already have cataract because of, I would say, presbyopia, in the sense age related changes, supplementing with vitamin E would show some improvement in the maintenance of the condition. So as you see over there, other, I would say, damages concerned with soft tissues or connective tissues, you do find varicose veins. So for people who complain of varicose veins, yeah, there is actually a different etiology. I don't mean to say varicose veins will be the result of vitamin E deficiency, but people who are already with varicose vein conditions or problems with the lymphatic drainage also tend to have, I would say, the problems getting worsened in the context of vitamin E deficiency. Then premature aging. So what is this? So this is again a inherited disease, and you do have lots of genetic markers. One clue says that many of these genetic markers pinpoint to more of oxidative damage happening inside the tissues. So there is bound to be oxidative damage or changes as we grow during the phases of cell maintenance and repair, and supplementing with vitamin E could actually improve the conditions. I would say the way in which the cells can handle the free radical load. Yeah, obviously acne, and especially you consider people who are in the transition state, who are more likely to develop free radical related damage among their cells. If they are going to supplement their diet with good doses of vitamin E, would really help the condition. Now, yeah, we finally come at the toxicity. Like any other vitamin, fat soluble vitamin, excess of vitamin E can actually become toxic, although it's quite rare. So you see over there, we have a very few side effects even at a very high dosage of 3200 international units. So you see, like, there would be soreness of mammillary glands, there would be fluctuation because of the neuronal related degenerative changes, which are, I would say, not exactly balanced or maintained. Then muscular weakness and gastrointestinal disorders. So you see over there, if you closely watch, many of the symptoms what we mentioned here appears to be kind of recurring with excessive vitamin E. To summarize, today we have seen various aspects of vitamin E antioxidant effect and its role that it can cause towards deficiency conditions, and we dwell more on what are different types of vitamin E deficiency on a long term basis. Although you do not have any classical vitamin E deficiency occurring in our system, but we do have lots of oxidative damage related conditions happening. So we addressed all those things today, and we are going to continue this session with more of vitamins in the coming sessions. Thank you.